Good afternoon, everybody. Welcome to our 5th AMI session, Introduction to Engineering Design, Principles of Engineering, Computer Integrated Manufacturing. In our last lesson, we considered some designs for the COVID-19 supply movement that we talked about. Basically, as a reminder, it was the idea that we could 3D print these face bands and add the plastic shield and help people who are first responders take care of the people who are in the most need right now. So I got a lot of really good feedback from you guys and a few things I haven't thought about. So I took all the information that you gave me and spent some time reflecting on that. One of the things that you said pretty loud and clear is that you are interested in being involved in some way. And there's a lot of effort going on all around the world. We understand that. And the 3D print technology is a great technology, and I think we all agreed with that. Now, some of you are concerned about getting involved because of where we are as far as what we know how to do, what's going on in the world right now, physically where you are and where you're locked in and those kinds of things. But many of you had some great suggestions on how we might be able to help in some way. So I want to spend a few minutes thinking about those things where you thought we were going to be able to help in some way. Okay, so let's take a look at the 3D technology before we move away from it and why so many people are using 3D technology to do this project. So right here behind me or on the screen now is our 3D printer. And if you look at it, it's actually a large format 3D printer compared to the recent ones we had that can print smaller objects. We have 4 of these, and even if we print these 2 at a time, which we could do, it would still take you around 2.5 hours to make one of them out of this kind of plastic. Now the plastic I'm talking about comes from the spool in the back. And there's 2 kinds of plastic we can use, ABS and PLA. PLA is just a kind of plastic. It's fairly brittle, it's easy to clean, but it won't hold up that long. So if you look at the features though, you can see we can print pretty high. Look at the size of this model that we have here. So we could stack these on top of each other and print up to 40 at a time. But still, the time to print 40 in the stack would be around 60 hours to produce 40. No way you cut it, it still takes around 1 hour and 15 minutes per brace, just the brace now, in a 3D printer, which is a great technology. The spool that you saw in the back here only costs around $35 to $40 per. And you can make a 40 stack out of it, so you're still producing these for pennies, less than $1 per, for sure. So why wouldn't we just go ahead and do that? Well, again, we only have 4, so if you do the math on that, we could only produce 40 of these in 40 hours, which is a full week, times 4. So quick math. That's still 1 per hour times 4. And I think we can do better with that with a different kind of technology that we might have access to. And you thought so too. Welcome to another part of my lab. This is where I spend a good bit of my time. This is a workshop garage, but inside of here, behind me, you see what's called the CNC machine. Now I'm going to turn the camera around and give you a little bit of a tour of what a CNC machine is. We have 2 of these in the back. You probably already noticed them. They're the big blue cutting robots. And then there's little ones that sit on the outside of the counters where the computers are. So according to your suggestions, many of you thought that maybe cutting these out might be the best way, using a cutting robot. So I'm going to show you a little bit about how that works, and then we're going to think about a design where we might actually be able to use that kind of technology as opposed to 3D printing. Then we'll run the math again and see if it makes sense. Alright, so let me turn you around and show you a little bit about how this machine works. Alright, so now let's unveil it a little bit, and what you see behind me here is a full-blown CNC machine. This one's only a little bit larger than the one we have, the 2 that we have back in the school. One of them, of course, is in that big blue box, and the other one's kind of out in the open. And I believe many of you have seen them work before. But this one's about the same size. It just, the color is different. But other than that, it's basically the same technology. So as we turn around here, you're going to see that there's a computer part. And that's where the instructions for the design go in. This was a faceplate on a 3D printer, but basically there's a computer inside these machines that tell it, what to do. So this is the robotic part, and this is the part that will do the work. So as you kind of move in here, you can see that kind of like a drill, it has this cutting thing here. But unlike a drill, this one's very, very tough, and it's expected to go inside of the machine in here. In order to do that, we put it inside this thing called a collet. So this will lock into this place right here. See if I can get a good picture for you. So that'll lock that in place right there. And then the bit, which rolled over here, goes in place and turns it on, and it'll come down and just cut this into whatever shape we want. So the main thing about this is not so much the actual tool. We can get the right size cutting bit for whatever material it is. It's really what material should we be using. This is just a piece of polyvinyl polycarbonate, but it'll cut all sorts of different things. Like it could cut this kind of plastic material, this kind of thick plastic that you see in shores, your safety glass. It's really not glass, it's plastic. Of course, you can cut traditional things like wood or even hard metals. So what I'd like for us to do today, though, is consider if we're going to use this kind of technology, which is very, very fast, what is the design that will get what we need? And then once we have the design, what material should we be using it? So we really do have two questions if we're going to use this kind of technology to solve the problem. Okay, so now you see that we have some choices of materials to use. But we need to break down the design, because I believe the design here will tell us more about the materials than the materials will tell us more about the design. So what I have here is a COVID-19 shield that's been approved for use in Europe. Some of your comments had a lot to do with didn't want to produce anything that wasn't approved for use in hospitals. And I understand that. So I went out and found this design that was out there. And you can see from the design, if you look at it closely. Now don't beat up my technical drawing. I know I broke a lot of the rules here, but just trying to get some general sizes in inches to make it easier for you to see. We'll come back to technical drawings later if we need them. Let's go ahead and look at this design and break it down. Obviously we're looking at it from the top down. In the back you have these little braces here. The idea is that you would take a rubber band and you would just basically hook it one on both sides, and it would hold it closed near the back. Kind of like the same part of the strap would be in a baseball cap. So, and because the material's thin, it would flex a little bit but not too much. The forehead would rest here, and the plastic shield, the part that goes in front of the face, would have 2 holes in front, 2 holes in the side, and then little hooks that would keep them in. So this is their design, and they're very happy with it. So this design here is the European design, and I've already explained it. So let's look at the design that we examined yesterday out of Chicago, the COVID supply project design. Now it looks like this. It's intended to be 3D printed. This is a big hole right here. You've seen this design. A hole in front, a hole on the side, and then that's what would hold the plastic sheet in place. And then a rubber band, a piece of elastic actually, would be attached to this side here and this side here, and then it would hold it in the back. That design doesn't lend itself too well to the CNC, so a gentleman online named Lowell redesigned this one so it would cut better on a CNC machine. I made a few minor modifications to it, and it looks like this. So roughly it has the same front and back profile. This would just be solid material. We would cut around the outside edges. There's still 2 holes in front, 2 in the side, and a piece of elastic an elastic band would hold it in the back. But otherwise, this profile and this profile are virtually the same. This is the one that would be easier to cut out in a material that's a little heavier than, say, plastic. So we're going to call this Lowell design, Design 1, the Chicago COVID supply design, with some slight modifications for use in a CNC machine as opposed to the 3D version. And we'll call this one Design 2. We'll just call it the European version for now. So my question to you is, take a look at both of these designs. I'm going to post PDFs, a version of the file that you can just pull up and look at. Which one do you believe is a better design for work with a cutting robot? And that we would likely to be able to find materials to cut it out of. So those are our two questions. Which design do you like the most? And which one lends itself best to use out of something that we cut out of, which we'll decide later. All right. So I think you had the questions. Please read the instructions on the page where you're finding this video. Upload your suggestions as an assignment, and then later we'll discuss these once I've collected some of your thoughts. It's good seeing you all again. I hope everybody stays safe and healthy. Take care now. Bye-bye.